Okay.
We'll give it a few more minutes for people. I am. Anything. Okay. So why do we care about HTTP? So the rationale for this talk is you've gone to the kickoff, you've inspected elements, you know, you're ready, and you want to move on to the next step and start solving some like medium web challenges, right? And there's this missing step you're missing that's going to explain how the web works, how all these messages get passed around, and that's HTTP. So this is a really foundational technology for anything web-based. So the first part is, this is kind of continuing on from networking 1, but if you haven't seen it, it's not that important, is how do we talk to things over the internet, right? So we have this technology called TCP, right? And you can use TCP to talk to someone, but it's a bit of a mess. You have a pipe that you can send bytes on and you can read bytes from. Both sides can send and receive. There's no real structure to it, right? So you have no structure for like how big a message is, how is a message organized? If you want to include some different like information with the message, how are you going to put it together? And it honestly just makes stuff really annoying. It's not good to work with as a developer. So to solve this, we use HTTP, which is built on top of TCP. And it's a way of structuring this data into something that's a little bit more reasonable. So HTTP is based around this idea of a request and a response. So instead of both sides just reading and writing at random, you never know what's going on, you always have a client that sends a request and a server that sends a response back, right? So you're going to communicate in these like whole number of units of messages where each message is like an entire standalone thing. So we're going to be talking about HTTP 1, which is plain text. HTTP 2 and 3 exist and they're a bit different, but honestly, you don't really have to worry about them. Pretty much everything is compatible with 1 still. So HTTP has some nice properties where it's plain text and human readable, which means you can just look at the bytes of an HTTP message and tell what it is. You don't need to use any like special tools or like code to figure out what's going on. And each message is going to have a header and a body. So here is an example, right? So this request has a bunch of different parts. Over here on the right, you can see the full thing. And when we send the request, this isn't like some special printed form of the request. This just is what we send over the network, right? So a few different parts. So that very first part in green, lime green, get is the method, right? And when we have this request, the method determines what we want the request to do. So you might wonder, like, what do you mean by that? Like, what does a get do? And the answer is it's kind of up to the server. A lot of these parts of the HTTP request are just a place you can put data. What you do with that data is really up to the server. But for now, at least, just know that we have this method and it does something. If we want to get something, it's probably going to be a get. Okay, I'm very confused. Okay, that's gone. We're going to have a path, right? And the path is going to be the thing we want. So this request in particular, by the way, is getting a file, right? So we have get because we want to get the file, and then the path is the path of the file. So it's just it looks very similar to a Linux file path, and that's intentional. They're pretty much the same thing. So we just have this path to file.html. Next, we have this version. It's just HTTP 1.1. That's all you really have to worry about for now. And then these headers. So headers can do all sorts of things. Some of them are important to HTTP. Some of them are just extra added on info. For now, really don't worry about them. Just know that they are a key value store. So we have the key, which is the part before the colon, and the value, which is the part after the colon. For most ones, don't worry about the details too much. And then I also mentioned that the request is going to have a body, right? So these are all the like the header part of it. And then we also have a body, and that body can really be anything. So it's just arbitrary data. For this one, because we're just getting a file, we don't have any body. It's just this request. So now we have our response from the server. So our response is going to have a lot of similar parts to the header. Similar things to the request. So it's going to have a version, and then next to that, it's going to have this status code. So the status code is the server's way of telling you what is going on. So there's a big list of these codes online that you can find. You really don't have to worry about them too much. Just know that numbers that start in 200 means something good happened. Numbers that start with 400 means the client messed up. And numbers that start with 500 means the server messed up. So we successfully found our file. So it's going to return us a 200. Everything is okay. Then we have headers again. So these are just, key value for different details about the request. And then down here we have a body. So unlike the request, the body is not empty this time. And for this one, the body is just the contents of the file, right? So both this request and the response have a body, right? And this body can be any arbitrary data. And for different purposes, you'll use different things. So for websites, most of the time, the body is going to be HTML. If you're getting a file, the body could be binary data. There's something called form encoded data, which is used when you submit forms. And then other times you'll use JSON and XML. Don't get intimidated by this big list of different acronyms and technologies. At the end of the day, they're all just different ways to structure data. And you can really just Google them when you run into them. They're not super complicated. So now that we have these requests and responses, we have some server. How is that server going to determine what do we send back when we get a request? How do we handle these requests? So the way that most what we're going to call web servers handle them is when you get a request, you give it a file, right? So for example, if we request example.com ABC, it's going to return the file ABC, right? Now, there's obviously going to be a problem where we don't want to give people any file. The file is sensitive. It's private. We don't want to give that. So because of that, we'll have something called a web root, which is a special folder where we tell the web server only return stuff from inside this folder. So Apache is a really common web server, and its default web root is var www.html. So every request you give Apache is going to be relative to that web root. So web servers are super simple. You just point them at a directory, and they give that directory. They might return the file contents verbatim. So if you have a static website, this is generally how they work. You just have a folder full of HTML. And the web server just sends those full files back when they're requested, or it might do something with the file. So there's this technology called PHP, which is a way of making dynamic websites. And pretty much the idea is instead of just having some HTML and giving it back, you have code. And when someone requests that file, you run the code, then give the output back. So web servers are really a bit of an older way, but still a really standard way to serve stuff over the internet. Apache is the most common, which is why we used it as an example here. So before we move on, I know that was a little fast, but any questions about how exactly HTTP works and how servers are going to respond to requests? Okay, all good? So the second part is going to be REST APIs. So we already talked about web servers, right? And that's one way of handling requests. You just respond with some file. REST APIs are a different way of handling requests. So REST is a philosophy, not a technology. And, lots of people love getting into arguments about what exactly REST is and what is and isn't REST. Honestly, don't worry about that too much. Everyone misuses the term. But just know that a REST API, instead of just returning some files, we're going to be running code to generate data, right? So REST APIs are super common as a way to to query and edit data that everyone can deal with. Every programming language can deal with REST. So remember those HTTP methods I kind of glossed over before, like get, post, delete, all that. So REST is going to use those a lot. So we're going to have a motivating example. So we are the proud owner of a widget company. We have a database of widgets. We need everyone to be able to query and edit them from a bunch of different apps. So your phone, your browser, your desktop computer, all of this has to deal with the same database. So our database has widgets, they have an ID and a name. So the idea of REST is that we map these HTTP verbs or methods into some action. So a quest to each of these things with a different method will do a different thing. So a get request will return a widget, while a post request will make a widget. You know, a delete request will delete a widget. And the second idea that's central to REST is we identify stuff based on the URL. So you notice that we have this ID parameter. This will be a bit clearer when I go to the example. So like before, we said if you do a get to /widgets, you're going to return a list of all widgets, right? So we have here's the request. So we have a get to /widgets, and here is the response. So you see we've returned a list of all widgets. And the way we are organizing this data is something called JSON. That's one of those acronyms I mentioned earlier. But you know, JSON is not magic. We could organize this data really in any way. This is just what we chose to use. So then we have this widgets ID, right? The idea is if we want to speak to a specific widget, we put that widget's ID in the URL, right? So instead of just getting /widgets, we're now getting widget 10, and it will return just the data for widget 10, right? And then the idea is we can extend this to all of the other verbs I mentioned. So if we wanted to delete widget 10, we would do a delete request to this /widgets 10. You know, if we wanted to update this widget, we would do a patch to widgets 10. So REST APIs like this are generally how databases are exposed and people can view and edit them. And there's a lot of different ways that you can design your API, but generally we have the method to tell you what to do and the URL to tell you what to do it to. And now the correlation between these paths and the data in our database is completely up to the programmer. So just because we have an endpoint for some data, you know, that data could be coming from anywhere. Generally, it's going to be coming from a database like I've been using as an example, but it could be just like directly generated. It could be from a file. It could be changed every time. You can really do whatever you want with the REST. That's because, you know, it's a very specific, yep. Convey to the server to perform before REST? So really before REST, you just kind of did whatever you felt like. Like you had URL endpoints that return data and they, you know, just existed. You made stuff up on the fly. REST is just, oh, yeah, there's other ways of organizing it too. Like SOAP was big for a bit, but really REST is just a way of organizing HTTP endpoints, right? But it's not like it's magic, you know. Before REST, you can still do similar things. You just didn't have a nice philosophy to use to kind of organize everything together. So I said that we can do whatever we want, and that sounds, you know, very scary, but most REST services are pretty similar. So we're gonna have some like defaults. These aren't really rules, but if you look at REST services, this is just kind of how things tend to be. So the object we're querying tends to be JSON. Some older stuff will be, you know, like XML or form encoded, but JSON is the average. So this is an example of JSON here. It's just really a dictionary, you know, strings and numbers. It's nice because most languages support JSON and it can be parsed pretty easily. Sometimes these URLs will be preceded with a version. So for example, let's say we wanted multiple versions of our widget API. You know, we came out with widgets version 2. But if we just change all of our inputs to version 2, that's going to break all of the old stuff, right? So the solution to that is each version of the API gets its own URL. So that way, when you create a new version, all of the old stuff just uses the old version and nothing breaks. So each thing generally has its own complete set of endpoints. So this is the set I'm talking about where you have like 2 gets, post, put, patch, delete. So you have a set like that for each thing in your database. And I know thing is a very vague word, but it really depends on just what you're doing, you know? If you're selling books, then you're going to have a set of these for each type of book in your database, for example. And then there's also this idea of pagination. So sometimes your request responses get really big. So REST endpoints will split stuff up where instead of getting all million things at a time, you ask for it in pages. So like page 1 might be the first 100 entries, then page 2 might be the second 100 entries. And this is just a way to prevent requests from getting huge. So then one last thing, how are we going to interact with these APIs? So the first way is browsers. You've been doing this all your life. When you go to a website, you are sending a HTTP GET to that URL and it's returning HTML. So browsers can be used to do all sorts of stuff, but they're hard to control, they're hard to script. Browsers don't have support for really doing stuff with a lot of data you might get back. Obviously, they're good at looking at HTML, but if the endpoint returns JSON, maybe you want to do something else. So for CTF problems, we're generally not going to use browsers, though there is this technology called Burp Suite, which can be very useful, that lets you see all of the HTTP requests made by your browser. So the main way we're going to be dealing with these APIs and requests is through either a programming language or a command line tool. For a programming language, it really just depends. Every language has some way to send HTTP requests, and you're just going to have to look up your specific docs. And then for command line tools, you have a few different options. Curl is famous, everyone uses it. And then I like HTTP IE because it is the only one where I can remember how to use it without looking at the manual, which is nice. But they all do the same thing. They just let you send requests somewhere and display the response. And then the final thing is, this is a security club. How do these relate to security? Well, the very first thing is you can't exploit a system if you don't know how to talk to it, right? Pretty much any web system is going to talk over HTTP. And if you don't know how HTTP works, you're not going to be able to exploit it. So for CTF, knowing how to use these command line tools especially can be great for automating stuff. Maybe a challenge, you have to request 10,000 different websites, right? You don't want to be doing that by hand. If you know how to use curl, you can just for loop through it, right? And then also, challenges can be based on editing things. So, I talked about headers earlier. Sometimes a challenge might make you put a special header in that the server checks, stuff like that. HTTP is also super useful for software dev if y'all are interested in that. These APIs are the bridge between front ends and back ends. So like if the front end is like a website or a phone and it wants some data, most of the time it's going to talk over HTTP to a backend to get the data. And knowing how this works is super useful for debugging. If you know how to send requests using a command line app like curl, you can test like, does your backend even work? And then finally is application security. So number 1 on the OWASP top 10 is broken access control, which is literally just sending an HTTP request that the developers didn't expect you to do, right? A lot of exploits are just asking the server nicely for data you're not supposed to have. Yep. Oh, honestly, they're just a big corporation nonprofit thing that is in charge of saying what's a big problem. They're respected in the industry. They just publish a list of like the most prevalent security vulnerabilities for the year. Yeah, that. So I interned last year at a product security place, and a lot of the stuff I found was just sending a request to something the developers didn't realize was public, or editing data the developers didn't realize you could change. So knowing how to poke around with HTTP requests and edit fields and do weird stuff with them is super useful for that. So, yep.
Actually, is that like kind of didn't ask at the time, but what about 300? I'm pretty sure he's referring to when we were talking about this earlier on.
Wow, my computer just died. That is hilarious timing. 300 is redirected. So a 300 means nothing is wrong. Just go somewhere else to get your data. Yeah. Okay. Any questions? Oh, you know, I'm still in the Zoom. I'm still in the Zoom. My phone. No. My laptop has killed itself. It's dead. Yeah. It's fine. It's fine. Okay. Well, thank you for coming.
Sorry, is someone there? Sorry, are you there? Sorry, are you there? Hello? Anyone there? Is anyone there? Sorry, I was wondering, I had a follow-up question.